All right, so this is part 2. So for this one, notice that A is 2, B is negative 7, and C is 15. So in this case, multiply 2 times 15, negative 15 actually. So then find multiples of 2 times negative 15, which is negative 30. And we need to find the multiples that when we add them, they add to our B value, which in this case is negative 7. Okay, so then you can go down the list. If you see them right away, then you can stop there. But for this, it's actually 3 times negative 10, because 3 times negative 10 gives you negative 30, and negative 3 minus 10 is negative 7. So we can stop here. So then I'm going to rewrite this as 2x squared. I'm going to put the negative 10 with 2x squared, so minus 10x plus 3x minus 15. Then from this group, GCF of 2x, and from this group, GCF of 3. Okay, so we have 2x, and then this becomes x minus 5 plus 3 times x minus 5 again. So we have GCF of x minus 5. Let's factor it out. And then put together 2x plus 3. So this is factored completely. Okay, all right. Next example. So for this one, there's a GCF of 3, because 3 goes into 3, 21, and 36. So I'm going to factor that out first. So 3 times x squared plus 21 divided by 3, that's 7x. And 36 divided by 3, that's 12. Okay, so now we focus on this part only. Okay, so then let's find the multiples of, since A is 1, find the multiples of, in this case, 1 times 12, but those multiples have to add up to 7. So then find multiples of 12 that when we add them, they add to a 7. Well, 3 and 4 do that, right? Because 3 times 4 is 12 and 3 plus 4 is 7. Therefore, we have 3 outside. And then inside we have x squared. I'm going to put the, you can put whichever one, that doesn't make a difference. So I'm going to put 3x with the x squared. And then plus 4x plus 12. GCF of x here, GCF of 4 on this one. So then 3 times, we have x times x plus 3 plus 4 times x plus 3. Then we have the same binomial, which means we have a GCF in the two groups. So then don't lose that 3. So then we factor out x plus 3 times x plus 4, which is coming from those terms outside. So then this is the problem factored complete. Okay, one last example. So there's a negative lead. So for this one, I'm just going to add a note, and that is that we need to factor out lead negative first. So then negative, and then this becomes positive x squared. This changes to positive 2x, and this changes to minus 35. So now we need to find the multiples of a times c, which is 1. And c is the negative 35, so multiples of negative 35, because 1 times negative 35 is negative 35. We need to find the multiples of negative 35 that when we add them, they add to a b value, or a b value which is positive 2. Okay, so then notice that they add up to a negative number, and add up to a positive number, but when you multiply them, give you negative 35. So the only numbers that do this are negative 5 times 7, because negative 5 times 7 is negative 35. Negative 5 plus 7 is positive 2. So then let's not lose that negative lead. So x squared, I'm going to put the negative 5x with the x squared, and the 7x with the negative 35. Now notice you can switch them around, makes no difference. Okay, so then this GCF is x, GCF here is 7. So keep that negative outside. So we have x times x minus 5, okay, for the first group, plus 7 times another x minus 5 on the second group. So then we have x minus 5 and x minus 5 in the two groups, so then that's a GCF. So negative x minus 5, and then put together the x plus the 7 in another parentheses. And this is the answer, or this is that standard form quadratic in factor form. I hope this wasn't too bad. I'll see you in the classroom. Thank you for watching. Bye-bye.